is a series of monthly online lectures with renowned experts working in the field of climate change and development. The lectures provide an opportunity to share knowledge and have discussions on important topics and issues relevant to the climate discourse. That's why we are happy to invite you to our first e-lecture for 2022. Here we have the presenter of Dr. Shouro Dasgupta and Professor Elizabeth Robinson, this first e-series of ICCCAD-IUB e-lecture series. Over to Dr. Hawk.
Thank you very much, Dr. Nazneen, for introductions, and welcome to everybody who is joining us. As Nazneen mentioned, this is a series of monthly e-lectures that we organize from ICCCAD and IUB mainly for our students, but we also invite quite a lot of outsiders as well. Today, we are very pleased to have two very eminent speakers who are going to provide the lecture itself, and then we have a couple of designated discussants from our side, and I will be moderating the entire discussion. So the lecture's topic today is on the impact of climate and weather shocks on food security and health. And the main speaker is going to be Dr. Shouro Dasgupta, who is at the University of Venice in Italy. And he will be also assisted by Professor Elizabeth Robinson, who is with the Grantham Institute at the London School of Economics in London. We will hear from both of them first, and then we will have two designated discussants from my team in Dhaka, in ICCCAD. The first one is Badruddin Zion, and the second is Savio Rosario. They will have a few minutes to provide some comments and feedback, and then we will open it up for the floor for participants to ask questions. So if people have questions, feel free to put them in the chat box during the lecture, and then after the lecture is over, we will open it up, and if you want to speak, you can unmute and speak if you raise your hand. So without further ado, let me invite the first speaker, Dr. Shouro Dasgupta. Shouro, I'll also ask you to give a little bit more of a extended biography of what you have worked on before you give your presentation itself. Shouro, over to you.
Thank you, Professor Hawk. And it's always fantastic to speak at Bangladeshi events. I am, for those of you who don't know, I am Bangladeshi. I'll say this in Bangla, I'm Ashta Prishta Bangladeshi. I take bhat for lunch every day. So that's how Bangladeshi I am. So, and thank you, Professor Hawk, and your team at ICCCAD and IUB for inviting us. A little bit of background about myself. I work at the Econometric Center on Climate Change, CMCC, based in Venice, Italy. And I'm also a lecturer at the Foscari University of Venice. CMCC has offices all over, centers all across Italy. We have now 10 departments across 9 cities in Italy. I work at the Economic Impacts of Climate Change Division based in Venice. I'm an econometrician, an applied econometrician, and my work mainly focuses on climate change impacts on food security, a lot of that and all of it that with Professor Elizabeth Robinson. I also look at labor inequality, human health, and poverty implications in general. And I am currently part of the University of Venice Climate Change PhD program, so I can also share some information about that. We have every year about 8 scholarships for students to study climate change impacts in Venice or in Bologna. Do get in touch with me if you are interested to join our PhD program. Professor Robinson and I are also part of the Lancet Countdown, looking into climate change and human health globally. And today's lecture is born out of what we do in general, but also in the context of Lancet Countdown. I will give 2 sort of separate presentations, but Professor Robinson will tie them together at the end. Just for disclaimer, what we are presenting today is unpublished. I noticed that the event is being recorded. I ask you please not to share outside. than the participants here, and especially not to tweet some of our figures. But everything else is fine for internal discussion. And thank you very much. So with that, I will start my presentation. Just for housekeeping rules, if you have a clarifying question, feel free to interrupt me during my presentation. I do enjoy an interactive presentation, so that'd be absolutely fine. So let's start. The first part will look into climate change and child health. Of course, climate change affects child health in multiple and complex ways. And this impacts vary across time and space, both within and across countries. What we do need to do, oh, sorry, I'm not sharing, my apologies. Okay, let's try that again. So climate shocks and child health, this is where we start. This is again joint work with Professor Elizabeth Robinson. Of course, climate change affects human health in multiple and complex ways. This impacts vary across time and space, of course, across countries, but also within countries. What we try to do here is to understand some of these impacts using subnational data. So there are many studies on climate change and health. This is one of the most popular and expanding discipline across the climate change impact studies. But of course, very few provide attribution at the global level. A recent review, a fantastic review by Helden et al., they look at a very large number of studies, and they find that many studies include children or study children only as a subpopulation. There aren't many studies that actually look into impacts on child health specifically, especially at the global level. We try to fill this gap. While there are studies on or from low-income settings, most studies are still done, or majority of the studies that the Helden et al. Paper found were at high-income settings or from upper middle-income countries, or even focused on very particular countries. So this is a flowchart from the Helden et al. Paper showing the climate change and health pathways. We really like this diagram, and if you see this, you'll notice how complex this relationship is. And what we focus on today, or what we're going to focus on today, is the direct effects of temperature changes, precipitation and floods and droughts, and not wildfires, but those are our focus for today's paper. But of course, if you look at the wider graph, you will see there are natural fluctuations in terms of extreme weather, altered rainfall, raised temperatures in terms of maximum and average increases, sea level rise, acidification. And then, of course, on the very right-hand side, for the health effects, you have direct mortality and morbidity. You have changes in infectious diseases, respiratory diseases, mental health, something that needs to be prioritized, or mental health studies. And of course, other health effects concerning skin immunity or skin diseases, metabolic diseases, and so on. But the point of this figure is to show how complex this relationship between climate change and human health actually is, and how we often need to look at the entire context of this. What do we do specifically? We attempt to quantify some of these links between climatic stressors and child health at subnational level. For the purposes of this paper, we focus on mortality, malnutrition, stunting, and wasting. We look into both gradual and extreme climatic stressors, but at the same time, we control for many socioeconomic factors such as income, education level, poverty implications, and so on. This is a two-part analysis. In the first part, we empirically estimate child health exposure response functions. We combine, as I mentioned, subnational level health outcome data from nearly 120 countries with high resolution climatic data. I'm going to provide more information on our data in a little bit. We look at both gradual and extreme climatic events, controlling for income, education as modifiers to some of these impacts. In the second part, we combine our historical response functions that we estimate with updated future climatic scenarios to estimate or compute the future impacts of climate change on child health at the near global level. Data. Health indicators. So our health data set is aggregated from more than 600 household surveys, including DHS and MICS type surveys, which provides socioeconomic, health, and demographic information. These are aggregated using survey weights to provinces, states, or governorates levels within countries. So for Bangladesh, these are aggregated to the Zilla level. We have information from 1,300 subnational regions for 119 countries between 1991 and 2018. For extreme events, we control for 6 months SPI, or standardized precipitation index, which represents the number of standard deviations that the cumulative precipitation over a desired time scale deviates from the long-term median. So in our case, it's a 30-year time period that we use. We also control for heat waves as an extreme event indicator. So for our purpose, we look into warm spell duration index, which is calculated as the annual count of days that the daily maximum temperature of at least 6 consecutive days exceeded the 90th percentile. So you'll notice that in Bangladesh, we have a large number of heat wave days. Some definitions for health outcomes. So we look at neonatal mortality, which is number of neonates dying before 28 days of age in a given area per 1,000 live births. But we also look at infant mortality, which is child deaths below 1 year of age, under 5 mortality, below 5 years. But we also look at underweight, which is the percentage of children between 0 to 59 months in the area below -2 standard deviations. So, and the same with stunting, which looks at weight for height. And these are WHO standard WHO definitions. These are based on WHO child growth standards used globally. Some descriptive statistics. So we here provide information from, this is specific to our sample of 119 countries and nearly 1,300 subnational regions. And the table just shows where we stand, a snapshot over the 19-year period for which we have data. And equally importantly, this shows the special coverage of our data set. As you can see, most of the data comes from Asia and African countries and low and middle income countries for this. So I'll go into the econometric approach. So we use a non-linear econometric approach. So throughout the paper, we have used both quadratic and binned regressions. Our dependent variable is one of the indicators of child health that we just saw. For socioeconomic indicators, we control for IWI, International Wealth Index, which represents the income and wealth of a household in a given wave. But we also control for years of schooling, household size, dependency ratio, and a host of socioeconomic socioeconomic variables here. And as I've been talking about, we control for both gradual and extreme climatic stressors. We control for a host of fixed effects to control for unobserved heterogeneity across years and seasonality. And of course, we use survey year fixed effects as well. Our standard errors are clustered at the country level. These are boring information that I must give you, so you know that we have done this robustly. I will go into results. So our first task, as I mentioned, is that we estimate response functions. So this shows that temperature has a U-shaped relationship with all of our child health outcomes. So the interpretation is that as temperature increases, as we have warming, child health initially improves with warming. But beyond these thresholds that you see here, so 16.7 degree for child mortality, 18.9 degree for infant mortality, our child health outcomes actually decline. So as temperature increases, we do see child health improving across our data set, but beyond this threshold, our child health declines across the 120 countries. And the threshold or the minimum temperature is the lowest for neonatal mortality. Remember, the definition is childbirths or children dying below 28 days. So for that, we have the lowest optimal temperature, and makes sense if you think of it intuitively. Infants or neonates are the most vulnerable in the age groups, among the age groups that we study. Going more into results, you will see that larger household size generally leads to worsening health outcomes for children. So does higher dependency ratio. Both drought and heat waves increase mortality. However, they have no impact on shares of wasting and underweight children. IWI is something we focus on. IWI, as you remember, is the Income and Wealth Index. This is a standardized index to compare income and wealth across households, but also across subnational regions. So you'll see that we control for IWI itself, but also a interaction term. So the interaction term tells us that increases in income and wealth across subnational regions actually helps to modify some of the impact or the negative impacts of heat waves on child health. And this has important poverty implications. So as you improve income and wealth across subnational regions, some of the negative impacts of climate change can actually be negated. Some summary of this, of our empirical results. So we find nonlinear and convex relationship. As temperature increases, initially infant mortality, child mortality, and wasting and stunting declines to begin with. But beyond the thresholds we have shown, all the child health outcomes actually decline. Both drought and warm spell duration worsens child health. Education generally leads to an improvement. High dependency ratio leads to worsening health. We have discussed in detail that improvements in income and wealth conditions improves child health, but at the same time, it also acts as a modifier to negative impacts of heat waves when childbirths. So we have looked at some of these thresholds, but what about the countries? Where do they stand? As you can see, it's sort of a depressing, or not sort of, it is a depressing scenario that most of the countries in our data set are actually already beyond the optimal temperature thresholds that we estimate. So between 16.7 degrees and 19.6 degrees Celsius. Some countries that are actually within the mean temperature range are Iran, Lebanon, South Africa, Algeria, Syria, and Pakistan. However, many countries are already beyond this range, including Bangladesh, Zimbabwe, Malawi, Ethiopia, Uganda, and Kenya. So this brings us to an end in the first part of this paper. Now we go in and look into some of the projections. We estimate projections using climate input data from the 6th phase of CMIP5. So many of the current papers look at CMIP5, but we look at CMIP6. We use a multi-model mean to reduce bias and individual model uncertainty. So what we do is we compute future projections and compare them to a sort of a no climate change scenario of 1986 to 2005. So we have two temporal scenarios. One is between 2030 and 2050, which we call a medium-term scenario. And then we have a future or long-term scenario between 2050 and 2070. We will show results from 4 CMIP6 scenarios. The first one, SSP1, RCP 1.9, it reflects the Paris Agreement. So here, global temperature is expected to increase by 1.5 degrees Celsius above the pre-industrial levels. However, we know that we are sort of miserably failing that. SSP4, RCP 3.4, this is where global temperature is expected to increase by 2.7 degrees. This is the closest to Glasgow commitments. Then we have SSP2, RCP 4.5. This is where we are headed. Temperature is expected to increase by nearly 3 degrees. The final one is nearly catastrophic, where temperature is expected to increase by 3.6 degrees by 2100. We'll go to the results. I know I'm talking a lot. So this is a summary of our results. As you can see, that all child health outcomes are expected to decline due to climate change by 2050 and 2070 in almost all the scenarios. I will come down to why all. And if you, I will come down to why I said almost. And if you look at the box plots below, Southeast Asia and Africa, if you see those bar charts, that's where climate change impacts on child health are increasing across scenarios and over time as well. The interesting scenario is SSP1, RCP 1.9. You'll recall that this reflects Paris Agreement. So by 2050, the world is expected to reach a net zero outcome. So you will see that while this child health mortality and share of wasting and stunting increases by 2050, we notice declines by 2070. This is due to the fact that we are expected, or we should reach net zero by 2050 to achieve Paris target of 1.5 degrees Celsius. How reliable or how realistic that is a different matter, but this just shows the benefits of achieving these low emission scenarios in the context of climate and child health, that the lower we can keep emissions, the lower the temperature increases, the worse, the higher the benefits by reducing child mortality and share of wasting and stunting. And these are our special, this maps show the special heterogeneity. And as you can see, under the higher, so here we are comparing the Paris Agreement, which is SCP1, RCP 1.9, to where we are sort of headed. And as you can see that where we are headed is more red, which means more bad. I just showed two maps for the sake of time. So this is neonatal mortality, and this is the share of underweight children across the 120 countries, the increases due to climate change. Saudi Arabia, Chad, Kuwait, Burkina Faso will suffer the highest increases in child mortality in the medium term. However, in the long term, Sudan, Ethiopia, Kenya, Niger, Mali, and Mauritania will suffer the highest increases. And as you can see, as we discussed before, that many of the countries are currently on the brink of our estimates of optimal conditions, and we expect to see many of these countries go beyond the optimal ranges very soon. So this brings us to an end of the first paper. If there are no questions, I will go straight to the second one, which looks at climate change and food insecurity. Any questions?
I suggest you go ahead, Shouro.
Perfect, thank you. So now we switch to food security. In this paper, Professor Robinson and I, we explore and attempt to attribute climate change impacts on food security. We use prevalence of moderate or severe food insecurity data based on the FIES scales from FAO, and attempt to identify links between temperature anomaly and food insecurity. Just some background, in 2019, nearly 11% of the respondents suffered from severe food insecurity. This increased from 14.5% so this increased to 14.5% in 2020. Some of those impacts, some of those changes in 2020 are due to COVID, of course. If you look at moderate food insecurity, nearly 31% of the population that we have data from, so about 103 countries, goes into or have reported suffering from moderate food insecurity. This increased to 38% in 2020. Many of that increase is due to COVID. So this paper uses data from 83 countries, because here we're reporting until 2019. FIS, or Food Insecurity Experience Scale, asks households 8 separate questions, including whether they had to skip a meal, if they had to reduce the number of, portion, if they had to eat less healthy and nutritious food, if the household ran out of food, or if they went hungry for a whole day. So all these questions are asked and then aggregated to 2 indices that I talked about, the moderate food insecurity and of course the severe food insecurity. We combine this data with ERF5 land, which provides reanalyzed climatic data at 0.1 degree spatial resolution. So that's about 9 kilometer by 9 kilometer at the equator, and hourly temporal resolution. So our focus is very much on temperature anomaly here. We use data at the subnational level. We're using the geographical coordinates from the Gallup World Poll. We again use 6 months SPI, and we also control for subnational Human Development Index. A little bit on the methodology, but before we go into the methodology, look at this monthly global surface air temperature anomalies that we have at the bottom. It's really depressing. About just after 2002, it's mostly red. So the monthly anomalies have become positive. This is comparing to 1981 to 2010. So to track the impact of climate change on incidence of food insecurity, we use a standard panel regression, but coefficients that vary over time. I'll come into details in a little bit. The temperature anomaly is computed as the difference from mean temperature of a long-term mean of between 1981 and 2010. So a bit on the methodology. Most of the literature focuses on constant parameter coefficients. So it gives you the standard impact of a change in an independent variable on the dependent variable for the whole period of that you have data for. We posit that in the case of temperature anomaly and food security, this relationship is likely to vary over time. So we try to attempt to tease out the differential impact in different years. So this allows us to estimate whether the effect of temperature anomaly on food insecurity has actually evolved over time. So we have coefficients that vary over time, but also those that do not vary. And before I go into the results and tie this together, let's look at moderate food insecurity across countries. If you look at Bangladesh, so Bangladesh has reported about 30% moderate food insecurity over the last 6 years, but this is moderate food insecurity. And you notice that in Africa, these are much higher. These incidences are much higher. In terms of severe food insecurity, Bangladesh respondents report almost 10% severe food insecurity over the last 6 years or so. And again, comparing to the African countries, some of those report much higher incidences. So what does our time variant regression shows? We find that a 1 degree increase in temperature anomaly leads to or resulted in a 1.4% increase in global food insecurity in 2014. But this change was 1.64% in 2019. Impact on moderate to severe food insecurity is much higher. A 1 degree increase in temperature anomaly resulted in a 1.58% increase in moderate food insecurity in 2014, but a significantly higher 2.1% in 2019. So that's a standard increase, right? So we show what happens when there is a 1 degree increase in temperature anomaly and the corresponding increase in food insecurity. The graphs below show the increasing trajectory, right? So as this is why controlling for or running a time varying regression was important in this case. If you look at the middle graph, you will see that the impact of temperature anomaly over time has been increasing. It has been increasing for severe food insecurity as well, but the increases are much closer together. The left-hand side graph shows the actual temperature anomaly year by year. So to get the actual impact, we'll have to multiply the temperature anomaly in a given year. So let's say in 2018, this was about 0.6 degree by the coefficient. But again, the important message is that the impact of temperature anomaly has increased over time. The impact on food insecurity has increased over time. So again, in the second part of this paper, we ran a counterfactual analysis to sort of disentangle the extent to which historical climate change negated food security improvements. We compute the cumulative impacts of temperature anomaly over the historical norms over the 1981 to 2010 period. So we use data from the Detection and Attribution Model Intercomparison project of CMCC, merged with SSP2 RCP 4.5 data. So this sort of tells us what would have happened to food insecurity if essentially temperature anomaly stayed at the historical trend instead of the actual changes that we have seen between 2014 and 2019. And as you can see, food insecurity would have been lower. I'll give you one example of Africa. In Africa, moderate food insecurity would have been 2.25 percentage points lower if temperature followed historical trajectory. And as you can see that for all the regions, food insecurity would have been lower without climate change. And this is important, or this is importance of our counterfactual scenario. So in conclusion of this paper, we provide a comprehensive quantitative assessment of the extent to which climate change is already affecting food security. We find that the impact of temperature anomaly on food insecurity has increased over time. Our counterfactual analysis shows that climate change appears to have had a non-trivial impact on food insecurity. Africa has suffered the most due to climate change, but severe food insecurity has increased due to climate change in all the regions that we have data for. With that, I will end here and hand over to Professor Robinson. Liz, do you want me to keep sharing my screen?
Yes, please. Yeah. So I'll just talk for 2 minutes about the implications of our work. And thank you all for inviting both of us, and myself included. I must say I'm not Bangladeshi, but I spent a lot of time in Bangladesh in the late 1990s, possibly before some of you were born, looking as a practicing agricultural economist, mainly working on rice systems. So I have very fond memories of being out in the villages working on rice. So it's particularly exciting, even though I'm zooming in from London. It's really exciting to be involved in this lecture today. So I think that Shouro and I use secondary data to try to find these complex links, whether there are any, whether we can attribute worsening health outcomes, worsening food security to climate change. And so my job, just for the next couple of slides, is just to say, well, so what? So on the one hand, it's we kind of know things are getting worse, but it's really important still to have that rigorous data and to take the secondary data that's available and to see whether we can find those relationships. And we are. Second, I was thinking, quite often some people sort of say, well, there are some benefits to a warming climate. And Shouro showed that in those U-shaped curves. But for low and middle income countries, there is no warming benefit when it comes to health and food security. In all those countries, things will get worse as it progressively warms. And so the equity considerations are quite considerable there when we're looking at, again, higher income countries like where I'm from, where we caused the problem, and lower income countries which haven't caused the problem, but it's going to be even worse for them. So they don't even get that, oh, it won't be quite so cold in winter, which we will get in the UK. We'll get some of those little benefits. So it's getting worse. So first of all, of course, there's always that message that we need to more rapidly deal with mitigation. Well, that's fine at a global level. And, Professor Huck, myself, Shouro were at COP26. And of course, that was a key message. But then the message for right now is also, well, we've got to adapt much more rapidly. And so firstly, what our work is showing is just the increased pressure that climate change is going to put on public health services. And, there's going to be this sort of, well, there already is, we're experiencing this unraveling of all those good benefits of the efforts that have been put in by countries such as Bangladesh to improve public health, to reduce poverty, which of course has a long-term impact on growth as well. But also what we need to think about is, we've shown this secondary data at the sort of global level. Yes, we've got subnational data, but it becomes very clear that although the message is clear, we need to focus really hard on adaptation. That adaptation has to be very location specific. So it's not enough just to say we've got to act. Because there's limited funds and because there's limited time, we have to find where is the most appropriate place to act first. How do we do that? What are those localized policies that matter? And how fast can we act? And so I suppose, we've just sort of talked a little bit in this slide. I'm just going to talk about Shouro and I sort of discussed together the so what. What is our research really hinting at? Well, one, secondary data is great, but not enough. So we know that we need to start actually going into countries, working with NGOs, working with local researchers, working with policymakers. But there are some hints that we've got from other work that we've done and the literature. So for example, countries need to start prioritizing things like early warning systems. So we know ahead of time when it's likely to be particularly harmful conditions. Then we've got to, because again, that will reduce pressure on the health services. So what is needed, whether you're in a high income country or low income country? Access to cooling. Now that could be community centers with air conditioning, but it also could be urban green spaces. So we see that the message is not just to one ministry or another ministry, but this is something governments have to really look in a joined up way. Even improved building materials. We even talk about that, in Europe. Should we be focusing on air conditioning, which uses more electricity, or actually can we build better? And then, as I said, with early warning systems, just better information. So on the next slide, I just talk briefly about some of that broader context, which is on top of the climate change, our research does remind us all that it's, there's still those same things that matter. Your health outcomes are going to be worse if you're poorer. Your health outcomes are going to be worse if your parents' education is lower. So again, it sort of talks to, we've now got to deal with all these development indicators and climate change on top of that. And so, so if we go to the sort of next slide, the only point I want to just pick up on a little bit is that in lower income countries such as Bangladesh, when we're looking at the impact of climate change on health, quite often it's mediated through food production and food security. And so that's work we're doing at the moment to try and tease out which of these impacts, which I think econometricians don't like me talking about a black box, but to some extent, we have a black box at the moment from our input variables to our output. Now we're going to tease out a bit more of what's really going on. Is this food production and food security? Or is it heat affecting people in other ways? And, we can imagine some of those pathways that if you are a rural farmer, food production matters for your health outcomes, but also, the heat affects your labor supply, which can affect your ability to farm. If you're in a city, the heat might affect your labor supply, which gives you ability to have, enough income to feed your family, to go to the hospitals, to get the medicine to reduce those problems of stunting and wasting. If, health effects, for example, due to parasitic infections. So, we've just put a few examples of some of those appropriate location-specific policies at the bottom here. Improving smallholder agricultural productivity, safety nets. We've done a lot of work on safety nets in the context of COVID, and we find that safety nets such as food and cash transfers both matter. Cash transfers seem to be most important with COVID because the shock there was to incomes. But again, is cash or food better? Depends on local context. More broadly, the whole food supply chain needs to be looked at because of systemic risk. And then another issue we found is that storage actually really matters. And that could be storage of grain or actually savings and storage of cash. So whether you're saving grain or whether you're saving cash, that seems to matter. So those were just some of the sort of so what's, because hopefully when you're listening to Shouro, you're excited by this novel econometrics approaches, but also you were starting to think, well, so what? So I thought I'd start that off, and thank you so much. Thank you.
Thank you very much, Shouro and Elizabeth, for that lovely double act. one taking a deep dive into the data, and then the other one giving us the overall so what and way forward. A lovely presentation. Thank you very much. I appreciate that. We have two of my young colleagues we have asked to be designated as discussants. I'm going to give them the floor for a few minutes each, and then we'll open it up for further comments and questions. So if anybody in the audience wants to ask a question, you feel free to put it in the chat or raise your hand, and I'll invite you to speak once the two designated discussants have spoken. So let me hand over first to my young colleague, Zion. Zion, a few minutes, please.
Yes, sir. Thank you, sir. Thank you for sharing the exciting outcomes of global level research. Now, I would like to discuss some issues related to health and food security from local level. And going to the local level, climate change affects almost all aspects of human life, including health and the food security issues. This is particularly true in the densely populated and low-lying deltas like Bangladesh. However, the climate change nexus is relatively poorly explored domain of research, which is a cause of concern given the country's vulnerability to climate change. The impact of climate change on human health and well-being can be manifested through different pathways and can be categorized as being direct or indirect, which is illustrated in this article. So going to the child health perspective, the infectious diseases, the seasonal illness of the child, and the correlations between climatic events as well as the child health is very much well explored in this article. But however, the mental health, we are already having discussion that climate change is affecting the mental health, and there are very few evidence that are covering the mental health issues due to climate change impacts. And going to the food security issues, there is a big issue about balancing the agricultural production and environmental impacts. One of the key challenges facing the 21st century is producing enough food for the world's growing population while not undermining the ecosystem on which we depend for life. In particular, it is argued that the world needs to produce 70% more food by 2050. And if we fail to achieve this, then there will be major social and economic impacts. So considering these, the global food system currently releases about 25% of annual anthropogenic greenhouse gas emissions, causing about one third of terrestrial acidification and responsible for environmental pollution and eutrophication of surface water. So these are the conflicting issues that consider the climate change in the earth system. The earth system is causing the water security and the food security issues, causing health consequences, as well as we are destroying the environment that also causes the health consequences. So both are conflicting and both are interrelated, and there is a question raised that how we can incorporate all those aspects in an integrated way, and we can introduce the regenerative manners, how the earth can be saved and the people can live long as well as enjoy the good health. Thank you, sir.
Thank you very much, Leon. Excellent comments. Now let me go to the next designated discussant, Savio.
Yes, thank you, sir. Thank you for giving me the opportunity in the floor. And I would like to thank our presenters here today, Dr. Dasgupta and Dr. Robinson, for their insightful and informative presentation and work. So when we're talking about climate change and child health here, so children are vulnerable to heat stress because of their greater body surface ratio to their volume ratio. So that is a prime concern that we need to deal with. But when we are talking about our country, Bangladesh here, we don't have actually sufficient data. So while I was doing a research on this, I could not find sufficient data on it. So that is a major challenge what I have been facing in terms of when we are trying to relate climate change health, so the impacts of climate change and health. And talking about the agricultural sector, so as we see, I was going through this research a few days ago. So the impacts of climate change on agriculture and the extreme events, as the recently published IPCC AR6 report, it states that that climatic events, this extreme events are going to be more frequent in South Asia. So what happens here is, if we think of a farmer belonging to this region, and who is mostly dependent on on the nature and has very limited resources. So what happens here, because of the shift of temperature, the increase of temperature and shift of the rainfall, his harvest is being hampered. So what happens here is he can provide enough food to support his family, and then even if he takes loan from the bank, he does not have the means to refund it. So what happens, this actually leads to a mental health condition where he suffers from depression or anxiety. And in a very recent report in Maharashtra, India, there have been over 6,000 deaths of farmers due to this reason. So these are things that we can focus on. And one thing that I would like to mention again, that when we are dealing with climate change and the impacts of climate change on health and agriculture, we need sufficient data to work on this. So at the same time, we also need to have local capacity building, both structural and non-structural institutional capacity needs to be regarded here. So that's all from my answer. Thank you.
Thank you very much, Savio. Well done. Thank you both the discussants, Zion and Savio. We are now open for discussion. Anybody want to raise a question or a comment? I see Nazneen.
Thank you,
Nazneen,
sir. Yes.
go ahead.
Thank you very much, sir. Actually, I would like to put thank you very much for the thank you very much to presenter for an excellent paper, which is an important issue of children health related to climate change. Um, Actually, I would like to put issue raised on autism that as per the paper is under review, I'd like to say something to Dr. Dasgupta that as per WHO, 30% of children will born with autism spectrum by 2030. So environmental factor influencing the risk of autism and air pollution linked with increased risk of autism in children. So my question is, are increased autism cases in last few decades a hidden work of climate change impact on children health? If there is data, or are you going to get something from your study? Thank you.
Thank you, Nazneen. Shouro, do you want to answer that?
Yes, that's a very important question. So, and my response to that is that the existing surveys do not provide information on autism and autism spectrum, and which is very unfortunate. But going forward, I believe that the recent waves of DHS are collecting information, and so I think our next round of research will take that into account. I want to respond also to one of the comments for Bangladesh. Liz and I, along with another colleague of ours from Lancet Council, we are looking into climate impacts on child health in Bangladesh. So hopefully in the next few months, we'll be able to give an update on Bangladesh specific impacts. Thank you.
Great, thank you very much. So as we wait for any other comments or questions from the audience, let me provide a few feedback ideas from my side to both of you, Shouro and Liz. So first of all, thank you very much. We much appreciate you taking the time to share what you're doing. We, from our side, are very interested in exploring further collaboration with both the CMCC in Italy and the Grantham Institute and LSE in the UK. And there are three dimensions on which I would be personally very interested in exploring with you. The first one is obviously Bangladesh as a country case study. It's where we are located, where we do most of our work. We, by and large, are not a quantitative institute ourselves. We rely on quantitative data collection by others, but we connect with them. We can deal with them. We know them. We can bring them into the fold in discussions, facilitating, if you like, going forward. Then the second issue that we would be very interested in working on is this attribution of human-induced climate change, which Elizabeth referred to, and I've been having discussions with Freddie at the Imperial College, Grantham Institute about this as well. This is now a growing area of interest, and I often mention that in Bangladesh, I assert, and I believe I do so correctly, that the people of Bangladesh are the most climate change aware people anywhere in the world. People in Bangladesh all know about Jolavayu Parivartan, climate change, greenhouse gas emissions. This is now common knowledge. Now, not only is that awareness high, it has actually, the pendulum has swung too far in the wrong direction where everything is climate change. If it rains heavily, we say it's climate change. If we have a hot day, we say it's climate change. But then not everything is human-induced climate change, all right? So we need to be better at the attribution of what impacts are highly likely to be attributable to human-induced climate change, the 1 degree plus temperature rise due to greenhouse gas emissions, what are within the realms of normal variability of climatic events. And so we are very interested ourselves in getting better at this attribution science. And if you can help us with that and build our capacity to do that, we would be very it would help us a lot. We are not really attribution scientists ourselves, but we'd like to get to know better how to do it, and maybe our younger colleagues might go off to do PhDs on the subject. So over time, we can build up our knowledge and expertise. So I hope the remarks at the beginning by Shouro about potential PhDs in Italy, I will see several of my younger colleagues taking you up on that offer and exploring that possibility going forward. So we are talking about, PhDs over the coming half a decade or a decade, developing this capacity and knowledge, mutually working with each other. And then the third dimension is something that we do from our center in Bangladesh, which is running a network of universities in least developed countries in Asia and Africa. It's called the LDC Universities Consortium on Climate Change. And we have about a dozen at the moment, but we are in the process of getting more connected universities from least developed countries, mostly in Africa, by the way. And this network has already established working relationships, collaboration. Most of our work is primarily on adaptation to climate change, since we're all vulnerable countries, but there is some capacity in these universities, interest in these universities, not in English, or other least developed countries as well. In Shouro's talk, you named quite a few of the countries. Many of them are actually LDCs as well, and some of them we have LDC university partners in who might want to take on country level studies with you going forward. And the last comment I'll make is that we organize every year. Well, we have for many years run a platform in Bangladesh called Gobeshona, which is the Bangla word for research. And it's now currently more than 50 universities and research institutions, mostly in Bangladesh, but quite a few outside Bangladesh who work on Bangladesh. That's the original criteria for membership. And we have been collecting data, we have a website with more than 2,500 publications on a searchable database. We have monthly seminars, and we do a big annual conference. The next conference is coming up at the end of March. It's from the 27th of March to the 1st of April. And it's a conference on global locally led adaptation. That's our focus of our work, locally led adaptation. So we work very much at the retail level with people on the ground doing things rather than the big data level that you work on. But we need to find better ways of linking the two, where the people at the grassroots can benefit from the big data that you do, and perhaps their knowledge can feed into the analysis that you're doing as well. And that's something that we do very poorly at the moment, in my view. We don't link the global to the local well enough. And in fact, the theme for this conference that we'll be holding is linking local to global. And in particular, in the context of today's lecture, it is about data, about information. How do we make data from the global level useful for those working at the local level? And how can they collect data that might be useful for those of you who are working at the global data connection? So opportunities for us to go forward. I'll invite both of you to share some closing remarks. But in the meantime, I'd also like to ask everybody if they're willing to turn their cameras on so we can have a group photograph of everybody who is here with us today. So please do turn your cameras on, and let me hand back to first to Shouro and then to Elizabeth to close us off. Shouro, please.
You muted.
Yeah, thank you, Professor Hock, for those comments. We'd be delighted to collaborate with you and your team, and especially on the topics you mentioned. So we do have this work on Bangladesh ongoing, and we'll bring our some of our attribution work into that. Attribution is also new to us, but this is something we're going to focus on going forward, and we look forward to providing the evidence that we need in our country, in my country, to, well, as you said, attribution, but also bring this into the wider loss and damage debate, and how we as a team can collaborate on this. I'll leave it to Liz to close it, please.
Oh, thank you. Yeah, I was just going to say, thank you for those great discussion comments. I think, you know, I think it just raises how complex this issue and how interconnected. And I think this point about, you know, that we have to provide more food, and yet that's going to put more pressure on environmental services and ecosystem services. And it really is of greater concern. So it just emphasizes the urgency of us doing the right thing. I think the question on autism was really interesting because again, there are some win-win opportunities, such as reducing air pollution. So it's really important for countries to see those win-wins where there's an immediate impact benefit to the country. And then, you know, there's actually a global contribution as well in terms of the mitigation that's generally linked with reducing air pollution. So I think very insightful comments from the discussants. And of course, Professor Huck, I'm very excited to hear about the local to global, or global, linking local and global initiative. I think that's Shouro and I think about that a lot. So I think, you know, because we're working with the secondary data, but we're also really interested in what's going on in the ground. I think that's critically important area to go through. So yeah, thank you so much. It's been, I found the questions and the comments really made me think, which is great.
Excellent, excellent. So thank you all very much. Let me just, before I close, remind my younger colleagues that there is an offer on the table to do a PhD in Italy. Please to get in touch with Shouro if any of you are interested. I would certainly encourage you to do that. He's put his email address very kindly in the chat box. So please take it up with him. I'm sure he'll be able to help you apply and make use of this opportunity. I think one of the roles that you and I can play as universities is that younger generation of researchers. We can collectively together combined, we can take your students, you can take our students, and we can join forces in terms of generating knowledge that will be genuinely useful for decision makers, all the way from presidents and prime ministers of countries to farmers and fishers on the ground. And that's really the spectrum of users of information we need to be thinking about. And although, you know, doing research and writing good academic articles in peer-reviewed journals is our bread and butter, that can't be enough. We have to do much more than that. And I'm sure I'm speaking to the converted here, so I don't need to preach that to you. But we need to practice it. We need to put it into practice. And I think this is a good start. Let us continue the conversation going forward. So with that, let me thank everybody for being with us. I see Professor Ainun Nishat joined us for a little while as well. So thank you very much, sir, for being with us. And let's close it for now. And thank you. And we'll be in touch, Elizabeth and Shouro, for following up on these conversations. Goodbye, everybody.
Thank you very much.
Bye. Thank you.
Bye-bye.
Bye. Take care.